Hello and welcome back. In this mini episode, I just want to go back through some of the things that we did last video and just clean some things up that I noticed while editing it. The main one being, if we just scroll down here for a second, PushBuffer for VertexArray takes a pointer, and I talked about pointer ownership and sort of the caller should know that that the ownership of the pointer is moving to the vertex array. So I mean that's a perfect example of where to use a unique pointer. So I'm going to do that right now. That's the big thing that I noticed. Because we actually are or can be potentially leaking memory, and I'll show you that in 2 seconds. So here, PushBuffer had the potential to not move that pointer into the array, right? Like if it didn't pass this check, if I didn't have a proper layout, it wouldn't add it in, which means nobody would ever call delete on that VBO. So if I try to call this without setting the layout, sure, I'll get an assert, but I'm still going to be leaking memory because nobody's going to call delete on it. So really, if I was still using raw pointers, I should have called delete after, sort of in the else case. But I mean, this just makes a lot more sense. We're very clear now. The unique pointer lives within vertex array. It owns it, and we can just do it that way. Looks like I need memory here, so let's include memory. It's better. Yeah, so let's just go to main.cpp real quick and clean that up first. So this will no longer be a pointer that gets newed. This is going to be similar to our, it's going to be similar to our draw calls. And I think I'm going to want to do something like this. This like constructs it inline as well, which we don't need. But I do want, just because like otherwise, let's just write that line out and see what that looks like. It'll be stud unique pointer of graphics vertex buffer of floats VB equals stud make shared, make unique of graphics vertex buffer of floats. That's what the line looks like. So if I just hide that behind the macro, I could say something like hippo create vertex buffer. I would pass in the name and then the type, and it could do it all for me. So yeah, let's do that. Some people, yeah, I've said this before, some people don't really like macros. I think they're useful. I think I don't know, maybe there's a time and place for them. For me, it just makes my life easier if I can just write things out a little less verbose. So we'll do a define. Yeah, so this will be a stud unique pointer. Oh, sorry, this will take a name and the type. So we'll do stud unique pointer of graphics vertex buffer, and this will be type, and then name equals that of type. And I'll omit the semicolon so that the user of this macro has to do it themselves. So main.cpp, just like this, and yep, that should be fine. And now I have to stud move because this is a unique pointer. But I like that better, I think. So now this will be a VB of shorts, and then stud move here. Yeah, like much better. Vertex. Yeah, so if we don't push it back, it will go out of scope here. I've moved it into this scope now, so it lives within here. Until I move it, I can't push back. I have to move into the vertex, or sorry, into the vector. If I don't move it, I go to reach the end of the scope, which is the end of the lifetime of that unique pointer, and it will clean itself up. So that's good. And then, yeah, here in the destructor, I no longer have to do this. In fact, just a clear should do it, because a clear will destruct all the unique pointers to raw vertex buffers, and raw vertex buffer cleans itself up in its destructor. So just a clear will work here, instead of having to iterate over these and doing it myself. Cool, I like that. So that actually should be it. Let me just try and run that. Yep, so everything looks good. Nothing broke, so that's good. Okay, good. That was the main thing that was kind of bugging me after going back and editing the previous video. So moving on, I think the next thing that I looked at was I said vertex arrays have a valid bool, and I can ask for it, but I never set it or anything, right? Invalid. Yeah, I don't use it. So maybe I'll set it here. So the point of valid is that I don't want you to be able to try and render a vertex array that isn't uploaded because you won't get what you expect. Maybe here, so at the end of upload, once you've gone through all of your VBOs and you're done, we'll just do it at the end here, invalid equals true. I know we're not like doing any sort of error checking or anything, but really it's just really to track that we tried to upload, and if we couldn't, I guess we'd get an assert for here, if there was any sort of issue. Is M is valid? M is valid, yeah. Okay, cool. So that's step 1. Step 2 is in the render command. Here, when I try to render a vertex array, if VA and VA-arrow is valid, and else attempting to execute. Maybe I'll do this check internally so I can have a separate error message for it. So if is valid, then go ahead and do your thing. Else, then we can just say, because I want to be clear, like we're failing because you didn't call upload, right? So attempting to execute invalid render vertex array, and then did you forget to call vertex array : upload? Perfect, and we'll do the same down here. Oops. Okay, nice. Good, so that is the second thing on my list. The third one was that if we just switch back to main.cpp for a second, I mentioned that I have 2 buffers here. I'm pushing them both to vertex array, and the second buffer, this wouldn't work because I would assert, and actually I should be able to show that off. I said the first buffer that I push in to the vertex array will define the number of vertices that I expect per buffer. And so then I added some checking there, and I do assert properly, and it says you're asserting on vertex.cpp on line 76. That's here. So my sizes don't match. That's good. That's what I want. What I don't have the ability to test against is within the vertex buffer itself, like this, if I'm missing one from here, because all I'm doing is pushing back data that gets appended to an internal vector, right? I'm not doing any sort of size checking internally. So when I try to do something like this, for example, where I've got a layout of 3, 3, what's going to happen is, because it's just a contiguous array in memory when it gets uploaded, it's going to take the second vertex. It'll say, okay, X, Y, Z, U, V. Or sorry, this is color. So it'll say X, Y, Z, red, green, and then it won't have a blue. I didn't give it a blue here, but it's all contiguous. So it's going to go to the next value, which is this one. So it'll think this is the blue value, and then X, Y, Z, red, green, blue, X, Y, Z, right? So you see every vertex after that will be off by 1, or off by the number of things that I've omitted, or extraneous values that I might have there. So really, I want to do basically the same thing. When I push back the first vertex, that'll tell me how many values I'm expecting per vertex. And it ultimately should match the layout. I can't rely on the layout because I could, like I'm doing here, I'm setting the layout after all my vertices, so I can't rely on having a layout defined before I call push vertex. So I'll just have to do it the same way I did the sort of vertex array side of checks, where the first vertex I push in will tell me the number of values I expect. So let's do that real quick as well. Just switching back here, this will be a vertex buffer specific thing, and I'll just have an int, or maybe a uint32_t, m, let's call them elements. No, we'll call them values. M values, or M value count. I like that. So M value count, we can initialize it here to 0, and then push vertex if M value count is 0. So if it's unset, I guess I could also check for the size of mDataVec here, but I think this will be fine. Maybe not, because I think I can push an empty vector, right? And that might do something different. So yeah, maybe I'll just do mDataVec dot size. So if the size of the vector is 0, which means I haven't pushed anything back into it yet, then I'll set my mValues count to vert.size, right? So the number of vertices, or the number of values I pass in with this vertex, will be my value count internally, and then I'll just check against that afterwards. So first I'll assert that vert.size is greater than 0. I have to give it at least one thing, right? So otherwise, I'll say no values passed in for vertex. Simple. Okay, so confirm I have stuff, and then once I've done that, if I haven't pushed anything back into my vector yet, then from now on I expect this many things with every subsequent vertex. So that will only happen the first time I push it back, because mDataVec will be 0. And then here I can just check. So if vert.size is equals value count, right? Then I push it back. And then I can also assert on this, just like I do with the vertex array. Where did I do it? I did it here. Yeah, this. Yeah, it's the exact same check, basically. Vert.size equals and value count. And then otherwise, we'll say attempting to push a vertex with a different, well, let's just say with the incorrect, or with an unexpected number, or an unexpected amount of values. Ugh, that's not worded great, but whatever. Expected, and then I'll just print out the expected and value count. Good. So we'll do that, and then only if that worked, then we add our vertex count and push up to the back. Okay, good. That was the other thing, so let's test that now. We shouldn't see any changes if I run this. And we do. Too many arguments for function. Did I pass too many things? Oh yeah, I can't do that. I can't print in addition to an assert. I should probably look into why I can't do that. I think I just didn't set it up properly for asserts. Okay, we got something else here. So vertex main.cpp, this one 61. Oh, interesting. What's going on here? Oh, equals from conversion from size underscore t to un32 underscore t. Yep, un32 underscore t. Okay, so far so good. So nothing wrong there. And now if I switch over to main.cpp and do the test that I had before, where this would cause a bunch of issues, and it wouldn't be great because you wouldn't see it. It wouldn't necessarily be noticeable, right? But there, now we assert, and that's good. And I'm saying attempt to switch a vertex with unexpected number of values from vertex.h on line 93, and yep, that's perfect. So I can figure out that it comes from here. Okay, good. That's the other thing I had on my list. A minor one that I didn't want here is I added these because I usually do like to add those, but I usually only need to add those for prints. Asserts will literally tell you where it happened, what file and what line, so I didn't need to add that piece there. Good, and then I think the only thing I haven't tested yet that I should have probably tested earlier when I added it was not uploading a vertex attribute, or sorry, a vertex array. So this should just assert for me. And it doesn't. I guess I'm not asserting, I'm just warning. That might be fine. No, it shouldn't be fine. It's telling you that you've messed up. You've used the API incorrectly, so it probably should assert. Sorry, that's vertex.cpp. Now those render commands. .cpp, yeah, have hippo warn. Yeah, so I should actually do it this way. There we go. And then up top as well. This time it's a vertex array, not a vertex array textured. Get rid of the else. Okay, cool. So this should assert now and let me know exactly where, or exactly which vertex array I haven't called upload on yet, right? What happened? Did I put it back in? I might have put it back in. Yeah, I put it back in. Okay. There we go. So that asserts, and then this is the vertex array that's asserting, so that's good. Cool. Let's put that back in main.cpp, and I think that was pretty much all of it. Okay, so those are all the code changes I wanted to do, at least in Hippo Editor and Hippo Lib. The last thing I wanted to do, though, was remove the mesh class entirely, because I don't want it. It's outdated. I don't like it. Now, what I did do is remove the render commands from meshes themselves, so I might as well just delete mesh, because the whole point is that this vertex array class and API sort of makes this obsolete, and it's the preferred way of using it. Which sort of takes me to the next piece. I'll just rerun this real quick just to make sure we're all good. But it brings me to the next point of what I wanted to focus on today, which was I've been running, and sort of I did the previous video just here in Visual Studio, and I was just clicking load Windows Debugger, and it would just run the currently selected app to run, which is this one is the startup project. But if I was to build this through my CLI.bat, it would actually fail, because that will build the entire solution, which includes Pong v1. and we removed the render commands for render meshes, and we just deleted mesh class directly. So Pong v1 is still using the mesh API and therefore is now fully broken. You'll see that if you try to run this via CLI.bat. Now, usually, if this engine was like out and ready and sort of people were using it, we wouldn't introduce a breaking change like that, like deleting the mesh class, for example, or the render commands associated with them. But we would mark them as deprecated. People would know they're deprecated, and then eventually, a couple versions later, I could remove them entirely if I feel like I've given people enough time to sort of adapt to the new API. Obviously, this is a very young engine, nothing like nobody's using it. It's just us here, so I don't mind making breaking changes if they're for the better of the engine. But I didn't go through Pong v1 and update it because obviously all the stuff that it's using for meshes is gone. So yeah, I just try to run it and immediately get some errors. So I wanted to fix these up as well. So this should be relatively straightforward. This is a vertex array. We'll call this VA. Cool. And yeah, I was just going off of where it couldn't find. I guess it was just this twice. So yeah, okay. So this has a vertex array now. So the CPP should be fine. We just do render vertex array. Good. Oh, it doesn't like that. Why doesn't it like that? Oh, vertex array. Okay. There we go. And I think I was preparing these in factory, right? Yeah, factory is the other one. So factory should needs vertex. And then here, the elements will stay as is because we gotta just call set elements on the vertex array that we create. And this we can just pass in this vector of un32_t's called elements, and it won't be an array. That should be good. And then the vertices, that's fine, but we can't sort of define them like this. It'll have to be a std vector of floats, but for each vertex, right? Because our API expects us to call set vertex or push vertex for each vertex, because that's how it keeps track of the vertex of the vertices that we've got. Negative, negative. Let's just do it this way. Negative, negative, and then negative up here. 2, 3, 4. Good. So then down here, we won't just simply create a mesh. We will instead create first a vertex buffer, right? So hippo underscore create vertex buffer, and we'll call it VB with the type float. Okay, and then we'll do VB-arrow push vertex, and we'll do vertex 1, 2, 3, 4. This is what I was referring to earlier. Like, we can't push the entire array once because we actually calculate vertex count based on the number of pushes we do here. Alternatively, what we could do is just have like a set data. Actually, that's not bad. We could just do a set data. You take in the entirety of the data and then the number of vertices. Then we can set vertex count and copy the data over to mdataVec. And even after doing that, you could push an additional vertex after if you wanted to, and this would just keep working. That could be an interesting way to do it. I think for now, I'll just leave it as is, unless I find a bigger need for it than what I'm currently trying to do, which is really just retrofit our little game here. So yeah, that's fine. I'll keep it that way. And then we do a VB-arrow set layout, which will be 3. And then we can create our vertex array, call it VA. Our vertex array doesn't take anything in its constructor, but we will call VA-arrow PushBuffer, right? And we'll pass in a std move of VB. And then I think I also need to call set elements. Yep, and we have elements as well defined above. And that is actually it. That's all we need to do. Now we can just pass in VA here. So yes, our new API is a little more verbose. We knew that, but I think it's the trade-offs that make it worthwhile. So again, it's the same vertices and then the same elements. That's good. And then VA. Yeah, we were always using the same mesh here. Okay, good. I think that's it. Let's try and run that. Oh, and it dies. Graphics is not a class or namespace name. Oh yes, we don't have. Yeah, we should have hippo before this, because we'll need a fully qualified name because we're not guaranteed that somebody will use this macro from within a translation unit that calls using namespace hippo. I think we had to do the same thing for the render commands as well. Okay, and we're asserting. Oh, did I not? This is exactly why we have asserts, because I forgot to call upload, and I just added this one. That's perfect. Okay, good. Let's switch back to factory. I'm not uploading VA. Okay, let's run that. If we got that far though, that means we got all the way to try and render, so we should be good, and yes, we are. Perfect. Call start game. You can see everything works as expected. And that's pretty much all I wanted to get done, so let's just do one final verification here. Oops. Just regen, rebuild, run. And make sure that this works from CLI, which it does. Perfect. And if I try and CLI run -prj equals pong v1, that works as well. Great. I probably don't need these prints anymore, but I think they're fun. Now I thought this would also be a good time to check the other platforms to make sure everything's compiling. Mac is fine, but as you can see, Linux is not actually compiling right now. It looks to be an error with the assert that we just added. So if we take a read through it, it says that in vertex.h, in the VertexBuffer's templated classes upload method, there are no arguments to hippotrace that depend on a template parameter. So declaration of hippotrace must be available. And this is the line. Let's just switch over to VS Code real quick. So these are the lines here, the trace and the assert. And to understand why this is a problem, you have to understand how templates work. The compiler will go through anything templated in two steps, in two passes. The first pass will go through and try to compile anything that doesn't require knowledge of what T is, right? So without substituting T, what can I compile? And then the second pass goes through when you're within a translation unit actually defining T and using this class. That's when the T-specific lines get compiled. So in this case, we're in a method that doesn't care about T. We're trying to call trace, which doesn't care about T. It's just printing some stuff out with some local variables. So the compiler expects this to be defined. And what it's telling us is that there's no definition for what hippo trace is and hippo assert is. So we just need to come up here and include hippo log. And that's all there is to it. Clang and LLVM and even MS build must be able to get around it. And I mean, G++ even said that if we compile with -f permissive, then this error goes away. But basically that's what it was complaining about. So this is how you fix that there. So let's switch back and try and see if this works. So let's just go ahead and try and rebuild that. And yes, I can't run it because I am on my virtual machine today, but the compilation step is really what we were after fixing here. So with this, Linux is good. And that's it for today. Thank you so much for watching, and I'll see you next time.